Hello everyone. Today I would like to show you how easy it actually is to get your point clouds into your CAD drawings. And if you've got a laser scan or some drone data or some other source of point cloud data, you normally want to bring those point cloud data into your CAD drawing. Within Carlson, that's actually a pretty straightforward thing. So we can go to the point cloud menu, which brings up a little importing tool. And here now we can basically create a new project. Let's call that demo 1. Okay, now we've got the options to import clouds, to adjust some instrument data. Here are some process data options that we can look at later. And finally some outputs and scenes. Okay, let's start by importing a cloud. We've got quite a variety of options actually. You can use LiDAR data, scans, generic information, specific instruments like Leica or Quarryman formats, GeoTIFFs, coordinate files, and a whole lot. We'll go with a LiDAR option because in this case we've got some ground models that were provided by a government survey. This one here. Okay. So here we've got a point cloud. Gives me the information about the cloud, 17 million points. I can give it a custom name if I wanted, or I can just leave with the same name. I can adjust the source units. It's in meters already, so we're fine. So we're going to just say OK. It will read the data and generate a cloud. Now it's got the cloud here. Now I can decide to view it. I can create a new scene. The scene is basically just a visual tool for inspecting my cloud. I can give it a scene name if I wanted to. I can choose any of the ranges that I want to see, direct intensity in this case, and we'll start with the plan view and for perspective. So putting that on, scene gets created. Let's make that a little bit bigger here. So here we've got our cloud. This cloud is now only in this module. We haven't transferred it to our CAD drawing yet. Within Carlson, we've got a number of options where we can perform some actions on this one. We can either choose one of the action buttons here, or we can go to actions on this side. And we've got various selection criteria. I can choose a line or an area which I want to perform some actions on. I can do some edits. I can delete stuff. I can hide stuff. I can transform or scale my cloud data. I can create outputs from these clouds, which we're going to do in a second. But a very nice thing I just wanted to show are these extractions. So I've got the option in Carlson to have automatic extractions of features. That could be profiles, slopes, color lines, slices, buildings, other things. And if I want to go radical, I can go with a bare earth option. So the algorithm will then identify all the point cloud points that are actually on ground level and subtract all the non-ground level points from the cloud and replace them with interpolated ground level points, so that I can, with one fell swoop, eradicate buildings, power lines, trees, scrubs, whatever. Very powerful, works very well, but it does take a little bit of time, so I won't show it in this particular instance now. Now, when we do have this data, we can now transform it into various ways to get it into our drawing. One of the things I would like to do is to just change it. I'm going to the action button here and transform it into a grid. Well, we're going to use the boundary box as a boundary for our grid. In one grid, we can have a elevation method, either a local minimum, maximum, or average. Just choose the average. And we can either specify a number of cells or dimensional cells. In this case, we'll go with 5 by 5 meters. You can set that to anything that suits your data and suits your project. Obviously, the finer you set, the more grid points you generate, the bigger your file gets. So for speed's sakes, we'll just go very coarse with 10 by 10 meter in this instant. We'll say OK. And now it's going to create a grid. You can see it's a fairly straightforward process. I'm running this on a 4-year-old laptop, so it's still with sufficient speed. Now we can see here actually that the image has changed because now we've got the grid underneath it. In terms of our scene, we can now go and remove this, because it's just a viewer, we're not removing the grid as such. And we find the grid now here under the grids, and we're going to view it in a separate window. Let's make that a little bit bigger as well. So here we see the grid plots, the cells with a 10 by 10 meter. It's all unicolor, so not too much to look at on plan view. But if we go into the perspective view, we can see the differences. Here's clearly now the elevations that we have in our grid, as we see it from our laser sights. Okay, so we're happy with the action. So we're going to close all this. Now what we can do as well, we can take this grid and we're just going to, well, we've got two options. We can either export it as a grid file, or we can choose to directly draw it into our drawing. We're first going to export it. Now that puts it automatically into a Carlson grid file format. You can save it in the directory. It's doing its thing in the background here, and it has created my file already. So if I were to go into my render viewer now, go in there, pick up the file here. So we can see the file exists as a Carlson grid file. Obviously with a 10 by 10 meter resolution, it's a rather coarse depiction. But as I said, you can set it to any resolution you want. I could now take this Carlson grid file and use Carlson to draw that into my design file. Alternatively, I can just use the option Draw to CAD, give it a new layer name, and you see Here it is. Now this is now in my design file. If I pick the other elements, go into my view. Okay, it doesn't have the ortho photos because they are background images. But you can see now with the 3D mesh in this instance now being located properly in our design. And that took only a couple of minutes. Now this works equally well not only with surfaces, but you can do this as well with solids. You can use scans of buildings, you can use scans from underground cavities if you're in mining, you can use a scan from your quarry to update your surface model. You can use all sorts of inputs. As I said, you can either from public data or data you've generated yourself. You can use, if you're using photogrammetry, for example, something like Carlson PointCloud, you're flying your drones and convert your drone data, your drone photographs into your point clouds using CPC. You can use this data straight away as well. Likewise, on the output, we've now used a grid, but there we can output as points, we can output as triangulations, as solids directly. So there's a whole lot of options. You can see it's really a powerful tool to work with point clouds in CAD to use the information as a base information for your work and to continue from there. Okay, I hope you found this useful and thanks for watching. Bye-bye.